Many people have asked me this question: what's the difference between F test, Z test, and T test? And to explain this concept better with a practical example, I have taken many examples directly from Minitab to illustrate the difference between F test, Z test, and T test. Before we further move on, let me just give briefing about F test, Z test, and T test. F test is meant for to find out the variances of two or more the variables. For example, the gas, let's say input and output, you wanted to find out the variance, how much is there, then you can use F test. And F test, you will find it in Excel also. You can go to data analysis, you can find that F test to sample for variances. In the Minitab, you will find something called the variances, two sample variances. You can find it. That is you will not find the direct word called F test, but you will find two sample variances. Similarly, Z test. Z test and T test are closely related. Why? Because both are meant for mean to find out the mean is significant or not. But Z test is meant when the standard deviation is known, we can use Z test. For example, let's say one particular machine or device or any apparatus is known to give some standard deviation, then you will accept that and then you will perform Z test as such. Similarly, the last one is the T test. T test is meant for to find whether the variance, whether the means are significantly differ or not, right? All these tests are coming from the hypothesis family. We are going to do lot many examples and using the sample which is given in Minitab, and we are going to do it in so directly with all the examples and the interpretation directly in a Minitab. So I have opened the Minitab, and all I'm doing it, I'm going to file and open worksheet, and you can click here. So you can just say furnace, give OK. So this is we are interested only in BTU input and output, right? And you can find it here, stat, and then the two values, BTU input is coming from tamper 1 and BTU output is coming from tamper 2. We are going to perform those two tests, right? And go to stat and go to basic statistic. You will find two variances. As I said, the two variances are in the Excel, you will find F test. Both sample in one column. For example, let's say if you wanted to measure BTU input versus the tamper, you can easily find it out. Let's say we want like that, we can easily find out. Or you wanted to find it in its own column, that is sample 1 and sample 2. Let's say we wanted to find out sample 1 and sample 2. And in options, I'm gonna keep it like 95% confidence, and graph, I'm going to select the histogram also and give OK, and result the same thing. Okay, so you can find that histogram has come up, and more importantly, we're going to find out this value. So when you say variances, you have a two theorem. One is distribution, Bonnet test, and Levin test. So you can see here the value is 0.92. I'll tell you how that 0.92 has been calculated. This is nothing but BTU input divided by BTU output, right? The gas has been measured in the input and output has been measured. And then standard deviation. So here the standard deviation from standpoint, it is 2.8. So how the standard deviation is calculated? 0.92, if you square up, you will find this value. And if you square this 0.928, and you will find this value. So this standard deviation also find out. And then almost close together. And for more detail, you can go to session folder. In the session folder, you can find here, this is the important aspect. Null hypothesis, if BTU input divided by output, if it is equal to 1, and here, for example, here the variance is 10 and here also variance is 10, then we can say null hypothesis, both are same. If it is different, For example, let's say anything which is not equal to 1 is called alternate hypothesis, and the confidence significant level we are going to go with 0.05. That means 95% confidence. And you can see here the variance between input n equal to 10 and standard deviation, variance, everything. And the ratio of standard deviation, how it has been calculated is 8.225 divided by 9.5. For example, even if you do it in Excel, you will end up having the same value. For example, I've already done here 8.5 divided by 9.2 is 0.92, right? So this is what it is. This has been showing up, and the ratio of variance and the standard deviation is also found, and variance also found, right? So these two, this first one is a standard deviation 2.8 divided by 3, and the other one is 8.2 divided by 9.5. And then you can also find that method. There are two methods, Bonnet and Levin. So you can find the what is the significant value 0.5, and that means we are going to accept the null hypothesis as an individual point of view, right? And so this is how it is. The variance is coming from the both the one, and if you go only by the variances, and you will find the ratio of that, then this is not equal to 1 because it is 0.862, right? I hope you find it useful. Another example will take it to understand this is better. You can right click here. For example, you can just do a right click here. You will find stat guide. In this, through the stat guide also you can find it. In the stat guide, you will find this is the one which we discuss, right? So now we have another sample. So this is the sample one. A recent study compared driver of two type of roads. Each driver drove on one of the two roads types. First class road, and that is one. The dirt road, that is two. As a measure of driving performance, the tester recorded the number of steering correction each driver made on each type of the road, that is 1 and 2. You want to test if the driver performance were equally variable across the two road condition. Road.mtw, it is there. So you can just go to file, look in Minitab sample data folder, and you can find road.mtw. Click here. So this is the road type. So 1 and 2, that is road 1 is the neat road, and the road 2 is that dirt road, right? That's what they have given. And then correction, how much steering correction they have done. Go to stat, and you can go to two samples, two variances, and are in one column. I will give F3 so that it will clear out samples. So how much correction been done, steering correction, and what's the sample ID, that is road type 1 and 2. Give OK. You will find here that according to Bonnet, so it is 0.82, and according to Levin, it is 0.823. And road 1, you can see that variance is, this is standard deviation, sorry, 4.8, and this one is 5.8. The standard deviation is different, right? So dirt road has more standard deviation than the safe road. So you can also see that the box plot also as well. This is very, very interesting, and the significant value also you can find it. For more information, you can go to session folder also. For example, in the session folder, it says that if the, let me go back here. So null hypothesis, standard deviation 1 divided by standard deviation 2, that is, variance 1 divided by variance 2. That is, or you can also say that standard deviation. So we can see 1. And then if it is not equal to 1, it is alternate hypothesis. You can find here the standard deviation is 0.82, that is 4.8 divided by 5.8. And variance is 23 divided by 34, 0.67. You can also find that significant value. This is not significant from the individual point of view, and you can easily find it out this way. This is all about the test called F test, is also called two variances test. Now we are going to learn test called z-test. So to do the z-test, I'm just going to one sample z-test, and you can click here on help, and we're going to perform this example of z-test. Measurement were made on 9 widgets. You know, the distribution of measurement has historically been close to normal distribution with standard deviation of zero point 0.2. Because you know the standard deviation, you wish to test if the population mean is 5 and obtain 95% confidence. They're asking EXH and stat. So just go to EXH stat. Go to look in Minitab sample data folder. You can just type EXH dot stat. Give OK. Okay, so you can find here there are many samples are there, but we will be interested to find out only the values. So this is the values we have. So we can just click here, and then we have only one variable. So values in the question, it has been given the standard deviation is 0.2, and we are going to perform the hypothesis. Here 90, but here 90% they have asked confidence level. Graph, we can see histogram, box plot, all that, individual plot, everything. Give OK. So this is all about this is box plot. You can see here mean, and what is the value of box plot, median 4.7. This is box plot. I'll come back individual plot, and then histogram. But more importantly, what we're interested is that we're interested in z value, that is summary. You can find here the mean is 4.7, standard deviation is 0.2, standard error of mean. Standard error of mean is standard deviation divided by square root of n, that is 0.06, and the confidence level is this one. So you can easily find the value of whether they're significant or not. You can easily find out. When the standard deviation is known, we can easily find out the p-value, right? And then we can go back to the graph. In the graph, we can easily understand it better, right? For example, box plot, if you take it, so we can see here whether the values are different or not. So here the mean value is here, x bar, and then this is the, if you click here, and you will 4.7 is the median value. You can easily find the difference between mean and median. So with the help of 90% confidence, the same example they have given, and you can also find the interpretation also they have given in few lines. The box plot. So this is another sample, but actually like we can also do this sample also as well. This is gonna be sample 2 for us, right? But I'll give a summary from here. So the box plot of cooking oil data, maybe we'll read this one. Dietitian select the random sample of 13 bottle of cooking oil to determine if the mean percentage of saturated fat is different from the advertised 15%. Previously, research indicated the population standard deviation is 2.6%. And we are gonna do it cooking oil, right? So all I'm doing it, I'm just clicking here. We are gonna perform the z-test, but we are gonna perform is for only one. So go to file. In the file, you will find, look in Minitab sample data folder, cooking oil, give OK. Here fat content is only one data they have given. So we cannot perform two, we can perform only one, right? So you have here one sample t-test. Just click here, and I will give F3, and then this is the only value we have, fat content in the oil. So they have known standard deviation is 2.6%. Give OK. You can see here, if we consider 13 and 13 values, mean is 16.6. That much of fat we have, and the standard deviation is 2. and that is already we have given, and standard error of mean, and then this is the mean value. So this is what we it has been given in the Minitab. So this is the value which we already saw it. I hope you find it useful. This is all about Z test, one sample Z test. And the lastly we are gonna do it. So one we have done the F test, one we have done the Z test. Now we are gonna perform something called T test. T test we have done many things, but quickly as a comparison I will do it one. Maybe I will take two sample T tests. You can just click here help, and you will find many examples are there. For example, to sample furnace is an example which we did it before. I will go back to furnace and take it. And maybe what's the question? We can find it one more time, the question. In the example, so a study was performed in order to evaluate the effectiveness of two devices for improving the efficiency of gas home heating system. Energy consumption in the house was measured after one of the two devices was installed. The two devices were electrical vent tamper 1, and thermally activated vent tamper 2. Tamper 1 and tamper 2 devices are there, and the energy consumption in BTU input are stacked in one column with a grouping of tamper 1. Okay, they have stuck in one column containing identifier subscript to denote the population. Suppose that you perform the variance test and found no evidence of variance being unequally. Example 2, that does not have any variance. Now you want to compare the effectiveness of the two devices by determining whether or not any there is any evidence that the difference between the devices is different from zero, right? And we're gonna do it now. We're gonna do it for BTU input alone, because they have already declared that output there is no difference. Only input, BTU input, and ID is tamper 1 and tamper 2, and we're gonna give it. Okay, so you can see here. So this is we are talking about T test, that is tail test. Tail is meant for mean 9.9 and 10, and you can see here the standard deviation 3 and 2, 2.77, and then the standard error of mean is here. Standard error as mean is nothing but standard deviation divided by square root of n. And then you can find here the p value, that is very important one. So 0.7, that means all the tamper 1 and tamper 2 are not significant, both are same. If the value would have been lesser than 0.05, then we would have considered that whatever the lowest value could have considered that is better, tamper 1 or tamper 2. In this case, we are concluding that both are same, not having any significant difference. I hope you find this video very useful, because we have covered the F test, in other words, two variances. We covered Z test of the two samples. We also covered T test, right? All these three tests are meant for variable hypothesis testing. I hope you find it useful. Please stay tuned for more such update, and happy learning, and take good care.